Hello. So in this video we will talk about the law of sine. Last time we were talking about right angled triangles like we have here, and we have used these four different formulas from your you can find them in your formula booklet as well. So you have Pythagoras and the three others. Just remember that in your formula booklet, if you, for example, want to find or use this formula, sine of A, that is equal to the opposite, so that is A over here, and C is the hypotenuse, yeah, and so on. So never mind the letters A and C and so on. Remember to use the opposite and hypotenuse and the adjacent, like we talked about in class. In this video we will talk about the laws of sine, and you can use them in any triangle. There's no restriction, so the triangle does not have to be right. So if you have a situation like in this example where there are no right angles, you use either the laws of sine or you use the laws of cosine, which we will talk about in the next video. But in this video we'll only discuss the laws of sine. So as you see here, actually there are three formulas. Either this fraction is equal to the one with b, or this fraction is equal to this one over here, or the b's this part is equal to yeah, that part over here. So if we, for example, have this example we have here, and you want to calculate this length. So what is b? Then you look at this formula and you say, what do I want to find? I want to find small b, so I have to, my formula has to contain something with b. What do I know? I know the capital C, so the angle C, and the small c, so this is small c. Remember that the small letters are the sides, and this is small b, which we do not know what that is equal to. So at first we write up the formula we are going to use. So small b divided with sine b, that is equal to small c divided with sine of the angle capital C. So now we just insert the values. So b, this is our unknown. Then we take sine of 35 degrees, and that must be equal to c, which is 9, divided with sine of 70. So we just want to make b the subject now. And how do we do that? Well, we just multiply with this number down here on both sides. So we are left with a b. So b is equal to 9 over sine of 70 multiplied with sine of 35. You could of course write the sine of 35 up here in the numerator. It doesn't matter. So now what you do is you use your calculator to calculate that number, and it will give us an approximate value of the length of b. So I'll just bring out my calculator here. So I say 9 divided with sine of 70. Remember to use the dot. And we multiply with sine of 35. Add in a dot, so it will give us the approximate value. So this is approximately equal to 5.49, I think it was. Yeah. So we have calculated this length here. This is 5.49. Of course, it's easy to find angle A here. You just know that the sum of the angle is equal to 180. So you just subtract those two. Like, you just say 180 minus 70 minus 35, and this angle is 75. Once you know this angle, you can calculate this side over here by using the laws of sine. Again, this time you just have to use some of it containing the a, because now a is the unknown. But this was not a part of my example, but it's just to give you an understanding that you can continue with this one in this case. Another example, we have that here. So in this case, we want to calculate the angle C. Again, you look at the formula over here, so the laws of sine. You say, what do you want to find? You want to find a capital C, so the angle C. So it has to say something with that. And what do we know? The values we know, we have something with A. Okay, so the formula we will write is A over sine. A equals C over sine of C. Now you just insert the values. So A, that was 7, and the angle A is 40, so you insert that into the formula like here. This is equal to C, which is a small c, which is 9, and the unknown angle which we have here is capital C. So now you want to make C the subject in this equation. So first you multiply with sine C on both sides. Since the unknown is down here, you want to get rid of that fraction. So it's in the denominator here. So sorry, we multiply with it on both sides. So you have this. And it is equal to 9. Now I go up here. I multiply with sine 40 on both sides. So what you have is, I just do it one step at a time, so it doesn't go too fast. Of course, if you're good at algebra, you could maybe just do it in one turn. Now you divide with 7. So sine C equals what we have on the right hand side. You divide it with 7. And then you have to remember, what is the opposite of sine? Well, that is the inverse of sine. So you take the inverse of sine on both sides, so that you're left with angle C over on the left hand side. So you take sine, or the inverse of sine, to that fraction. And then we will do that on our calculator. So C is approximately equal to some number. So the inverse function of sine, so you have 9 multiplied with sine 40 divided with 7. You could add in a bracket here. You actually do not need it, but yeah, I just use. So the angle is, and you should check that your calculator write it like you have here, so it's okay. So it is 55.7 something, 0.7 degrees. So we have calculated this angle here. Again, if you want to calculate angle B, you just again take the sum of the angle is supposed to be equal to 180, and then you can calculate small b. Yeah, that's it for now, I guess. Just remember, I repeat this, these 4 formulas only holds in right angle triangles. And the new thing here is in non-right angle triangles. That's it.